This is the new LeakSeeker 89 by Electronic Design Specialists, which replaces the old LeakSeeker 82B that you probably have seen lots of videos on. There's some changes. The old 82B, as you recall, had one automatic one automatic mode and one manual high definition mode when you needed to adjust the offset. Now on the new LeakSeeker 89, instead of just one automatic mode, it's got 3 of them with no offset control at all. It also has a higher range. The old LeakSeeker 82B could measure from a dead short to 150 ohms and tell you where on the board within a 1/4 inch where the short was. The new LeakSeeker 89, instead of 150 ohms, goes up to 300 ohms. And again, it's got 3 different automatic settings, so it's a little bit easier to use. So we're going to go ahead and demonstrate it on how it works, and we're going to go ahead and use the same board that we used when we demonstrated the original EDS-89, the original LeakSeeker. So like the old one, you have your ground wire and you have your gold-plated probe. We've added a wire to the ground wire with a little solder tab here, so that if you're having trouble getting a good connection, you can just solder the wire to a good ground. Again, where the ground is important. I'm just going to clip it over here. This is a ground lead that just goes to this ground trace on this Pioneer amplifier. Now, to refresh your memory on these boards, you'll see the top trace is a blue color, the bottom one is a red color, which is a red one, which probably looks purple in the picture. The blue one has a short of 3.3 ohms, and the red one has a short of 4.7 ohms. We just made it different. Again, we could have made it 300 ohms too. LeakSeeker doesn't seem to care. It's got range up to 300 ohms anyway. So first we're going to do the blue trace. Now we don't know where the short is. We pretend we don't know where the short is. You and I already know where the short is. We've done this board before, and the short's over here. It's a 3.3 ohm resistor across a good diode simulating a leaky diode. So we know it's going to be this solder pad. But we're pretending we don't know that. So we're going to go ahead and put it on the lowest sensitivity for now, or trace. We'll increase the gain later on. So we'll reset it. Okay, so now LeakSeeker is going to be looking for a whole new short. So we don't know where it is. We're going to do the first solder trace we come to on the very, very end. So here's the very first solder trace. As you can see, LeakSeeker is calibrating itself. It's getting close. Okay, so now it found a window it's happy with. So now I'm going to go to the next solder pad along this trace, and it looks like this one. Watch LeakSeeker. See, it's a little higher. Now let's go back to the old pad just to compare. It's definitely lower. So we're definitely going in the right direction. Okay, next solder pad over here. Now did you see LeakSeeker? It just it went through 3 different windows that time. That's what the yelping was. Let's go back, lower, way back. So you can see there's a difference here between these solder pads as we're getting closer and closer to the short. There's the next one. You heard it. You saw the recalibrate. Went through 2 more windows. Just one just now. Back, and so on. Now before we find the short, because we already know where it is, I want to show you the sensitivity range and how much there is. As you see, there's not a lot of difference between here and here. It's 1/2 inch. You can barely hear the difference. So we're going to increase the gain. Instead of low, we're going to set it for medium. So now we're on medium. So we reset it again. And let's just start right over here, because we want to compare these 2 pads. That's where we were anyway. So let's just start here. Now see, LeakSeeker's doing a little bit of yelping now that it wasn't doing before, and that's because it's more sensitive. So again, it's not a matter of being unstable. See, it just yelped one more time and found another window it was happy with. Now let's go to the next pad. Watch what happens. You see, LeakSeeker went through a whole new window. It did the yelping. If we go back, huge difference. See, here to here, big difference. So it gives you an idea how sensitive it is, and that's still on the medium gain. We still have the high gain, which normally you're going to use on a very wide trace or on a multi-layer ground plane. Meantime, let's continue finding the shorts. So we're happily going along pad by pad. Here's the pad we were just at. Here's the next pad. Watch LeakSeeker as it calibrates. Okay, it's happy with that window. Let's go back to the old pad. Practically no reading. So we're going in the right direction. Next pad. Here it is. Went through about a dozen windows that time. Let's go to the old pad. No reading at all. So here's the pad we were just at. Okay, and here's where we know the short is, or we don't know it, but we know it. Okay, so you went through another dozen windows or so. Old pad, no reading at all. New pad. Continuing on past the short, notice the pitch is getting lower, even further, lower. So clearly that is where the short is. And again, we've already looked at it, and that's the 3.3 ohm resistor across the diode, simulating a shorted diode. So that is LeakSeeker in the basic form of how it works, just like the old LeakSeeker 82B. That's how LeakSeeker 89 works. It's a little more automatic, a little more sensitive, with a little more range. Okay, so you've seen the basic functions of the new LeakSeeker 89, pad hopping, and basically whichever pad that beeps the highest is where the shorted component is. And now we're going to do something that's even easier, that lazy people like to do, and that's called a thermal test. All components that short out either partially or fully become thermally sensitive. Obviously, when they're higher resistance, they're much more thermal. A dead short would be difficult to find, but something that's just 3 or 4 ohms usually is easy, and the higher resistances, and remember LeakSeeker 89 goes up to 300 ohms, they become wildly thermally defective, and you can find them just by blowing a little warm air through a little piece of heat shrink tubing, and that's what I do. So what we're going to do is, we already know that we have a short here. Basically, here's a capacitor, and I put a 4.7 ohm resistor across this capacitor, obviously simulating a shorted capacitor, shorted by 4.7 ohms. So we know it's on the solder pad. Of course, I'm going to pretend we don't know where it is. Instead of using the probe as we did in the first part of this video, we're going to use this probe, which comes with LeakSeeker, and basically this just plugs into LeakSeeker into the reference port. And when this in the normal test that you see here, it's simply joining the probe and the 3-wire test. Normally this is used separately for the 3-wire test, and we'll get to that in another video. For now, it's just joining it with the probe. So we know that there's a short somewhere along this red trace. You and I already know it's here, but we don't really know. So I'm going to say, okay, I don't care where, we can start anywhere. I'm just going to solder the wire right over here, just for no other reason that's convenient. It doesn't matter where you put it. So now the wire's soldered in, and that's joined. We're going to go ahead and press the reset button on LeakSeeker so it can find and calibrate itself to whatever window it finds happy. So we'll just let it calibrate now. Okay, and notice that we are in the medium trace position, which is the medium sensitivity. If you had something that wasn't that thermally defective, you might even want to put it on the high. That'll make it 10 times more sensitive. So we're going to pretend we don't know where the part is. Again, we already know it's here, but I'm just going to take my hot air and I'm just going to go all over till I hear a change in pitch. Listen for the pitch. LeakSeeker sounded like a pregnant parakeet. And that's because notice that the difference in change of resistance, even if it was just a few micro ohms, was enough to send LeakSeeker completely into a different window. So again, just to demonstrate it a second time, I'm going to press reset and let it calibrate itself to the short, which we know is that 4.7 ohm short across the capacitor. And just coming along here, a little warm air. So that's how you find thermally defective components on a board where it may be just too difficult to find it any other way. It may be a multi-layer board, too many traces, the traces might be too thin, your eyesight's not good enough anymore. As long as you know there's a trace is shorted, your ohm meter is going to show the same short on every pad. You can connect LeakSeeker to any one of those pads, it doesn't matter which one. And as you put a little warm air or cool air, if you want to use a can of Freon, but this is just a lot less expensive, just breathe on every component on the board back and forth like a grid pattern. Whichever component makes the LeakSeeker change in pitch, that's the bad part. And that concludes the thermal test.